Okay, welcome everybody. Welcome everybody to our class. Today, we will continue in what we was working yesterday. It will be a light class today also. So we'll finish the basic concepts of regular languages operation, which is part of handout 4 or week 4, but we'll not read the handout till I finish the example of non-deterministic finite automata, which will be on the next class, which will be on Thursday in the tutorial session. We will have almost two hour and a half class merged with our regular class time from 5:30 to 6:30. So we'll start around 3:30 our class, and we will continue the things. And after that, assignment 1 and 2 will be announced together. You have enough time to submit assignment 1 and enough time to submit assignment 2 as well. And also this weekend, I will put like approximate schedule when will be the quizzes and everything. We explained this yesterday. And also before next Thursday class, you will know what is the topic of each group and when is the designated presentation will be. However, the paper or the final report will be submitted at certain time at the end of the term before the final exams started. We don't have final exam in this course. However, I'll make it before final exam to submit the final report. And as I mentioned, that the presentation will be carried out using Zoom. Each member of the group should present. You have the freedom to let your video appear or not, but you have to share your screen with us in order to continue the presentation. Okay, let's share my screen. Okay, to continue in what we have yesterday in handout in class note 3. So we were talking about the dump state, and what do we mean by dump state? And there are some regular language and non-regular language. We will have this in the next handout, in handout 5, and a part of handout 4 also. We'll talk about this. But as I told you, to make the course more smooth and more understandable by students, I need to think to be in a sequence and logical manner, whatever covered in the handout. So you'll be aware about everything. When you read, you will understand. So as an example, if we were talking yesterday, like if I ask you to have a DFA, a deterministic finite automata for a language L2, which has a string X, where X, the length of X is a 3, where X belongs to 0 and 1. So I need any string in the length of 3, which is 3 digit or 3 symbols of that language. So if we start at a Q node, whatever, here we are concerned about the length of the string or substring. We are not concerned about the input itself, whatever was the symbol. So either from Q node, if I enter 0 or 1, I'll move to Q1, then I'll read the next symbol, which is 0 or 1, then the third symbol, which is either 0 and 1. Here we arrive at the cardinality of 3 of these strings. So Q3 will be the accept state. Then whatever, if I receive another digit, either 0 or 1, as much as many I have in the languages, I'll move to Q4 and whatever the input. So what is the dump state in our example? Q4 is the dump state. Q4 is the dump state in our example. Just to catch up from what we were taking yesterday. Now, we have 2 types of operations. We have a 2 type of operations. Some operation, we call it unary operation. And this unary operation, which will be the star, that we have it, the clean star or the sigma star or whatever A star. So this star will have as an input a language and as an output is another language. So unary. So we take one language and we have another language. But in binary operation like union and concatenation, we will have two languages as an input and one language as output. That's why we call it a binary operation. So the union and concatenation are a binary operations for the time being. So you have to understand that in regular languages, the operations are under class either one of two, either a unary operation or a binary operation. A unary operation, we will have as an input one language and we'll have an output. But in binary operation, we'll have two languages as an input and a third or as an output. So in union operation, assume that we have the languages called A, B, which belong or equal to clean star. So if we have a union, A, union B, and it's denoted by the letter U in Latin, of X, where X belongs to A or X belongs to B. So the new string X, it's either belong to A or belong to B, or. And now the concatenation operation, which is A dot B, or denoted as AB without the dot, it is the XY where X belongs to A and Y belongs to B. And here the order is important as we talked at the beginning of the course. So BA is different than AB. For example, if I have in A small b, and in B, I have infinite symbol, 1, 2, 3, etc. So what is A dot B or AB, which is A1, B1, A2, B2, A3, B3, and so on. So this is the concatenation. We merge two languages together. Each symbol of the first language will be concatenated to the all symbols in another language, and so on. The star operation, which is a concatenation of different symbols from x1, x2 to xk, where k is greater or equal to 0, and each xi belongs to A for all i's. So if I have a language consists of two symbols, 1, 0, 0, 0, 1, what is the A star? So if I have A0, which means the empty set, A to the power 0, which is the empty set, which is the epsilon. If I have A1, which will be the same set of A, which is 1, 0, 0, 1, 0, 0, 1. If I have 2, which means I have to repeat each symbol twice or merge any two symbols in that set. So if I have A square or A to the power 2, which means I'll have 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, or 1, 0, 1, 0, or 1, the other one, which is 1, 0, and 0, 0, 1, or 0, 0, 1, 1, 0, or 0, 0, 1, 0, 0, 1, etc. This is what we mean by the star, which is any combination between these symbols in the languages. So now we'll move to the non-determinism, which we touch up in handout 3 or in week 3. From a state Q on an input symbol A, the automating can go to multiple states. So the deterministic, we know the state. If we have a certain input, we have only one next state that we'll move on, or two. What do we mean by multiple state? It can go to 0 or more states. Either I can stay at the same state, or if it's epsilon, it can lead me to another state or stay at the same state where k is equal or greater or equal to 0. The computation happens simultaneously. So in the non-deterministic finite automaton, It is not going to this path or this path. No, the computation will be carried at the same time to all possible paths. Is that clear, guys? So the computation will take place at the same time to all possible paths. For example, if I have a Q node and if I receive a 1, I can go to Q1 or Q2. So the movement of computation from Q node to Q1 and Q2 will happen at the same time. And it will continue at the same time. And if you remember, we said the NFA, or the non-deterministic finite automata, one of the example is the parallel computing. What do we mean by parallel computing? Parallel computing, that all processes happen at the same time. Because these kind of a processor or the parallel can do the thing in parallel. So the computation happens simultaneously along each of these paths. Has epsilon transition? If there is epsilon transition from Qi to Qj with epsilon, then the automaton moves state Qi and Qj without reading the next input bit, which means when I put an epsilon transition, that means without an input, I will move to the next state. I will move to the next state. So again, different possible path, all computation will take a process at the same time, and it will move in the transition at the same time. If I have an epsilon transition, also without reading an input, I will move forward. Is that clear, guys? Is that clear? Okay. An input is accepted if there is some computation path that lead to an accepted state. So I'll take the computation at the same time to different path. If one of the paths lead to accepted state or to final state, then we will accept that input. Otherwise, it will not be accepted. Okay, what do we mean by non-deterministic finite automata, as we mentioned? Let's take this example to understand what's going on. Let's take this example to understand what's going on. Now, I start at the Q node. If I receive 0 or 1, I'll stay at the Q node. At the same time, if I receive a 1, I'll stay at the Q node, and at the same time, I'll move to Q1. At the same time, I have two paths. If I receive a 1, then I'll stay at the Q node. Also, at the same time, the computation will go to Q1. Then, if I receive 0 or epsilon, which means to Q2, I'll move to Q2. Also, then, if I receive a 1, I'll move to Q3. I'll move to Q3. And then either if I receive 0 or 1, I will stay at Q3. For example, if I'm at the Q node and I receive a 1, to which state I will move? I'll stay at the Q node. Also, the transition will take me to Q1. So Q node and the Q1 will be compute at the same time. If I'm at the Q1 and I receive a 1, nothing, empty set, I'll stay. If I'm at the Q1 and receive a 0, I'll move to Q2. If I'm at Q1 and I receive an epsilon, I'll stay at the Q1. Also, I'll move to Q2. So assume that we receive a 0 and epsilon then. So I can stay, or I receive a 1, then epsilon. So I'll stay at the Q0, I'll move to Q1 with epsilon. Also, I'll move to Q2 at the same time. So the transitions are labeled with symbol from the sets sigma epsilon, where it is equal to the alphabet union the epsilon. We add the epsilon to the alphabet that we have. Okay, let's consider this input. Let's consider this input. If we have a W for the above mentioned NFA, non-deterministic finite automata example that we have 0, 1, 0, 1, 1, 0. If we have this string, is this an accepted string, and how the transition will be with each bit read or symbol read or the symbol to be read. So if we are Q naught, we are at Q naught, which is the initial state, So what is the first symbol I will read? 0. I will read the 0 here. If I read a 0, I will stay at Q naught. No other option. So I'll stay at Q naught. I'm at Q naught and read 1, which is the next symbol here. Okay. If I'm at Q naught and I read a 1, I will stay at Q naught. At the same time, another computation will be carried out toward the Q1. So what we'll put here, we are at the Q naught and the Q1. Okay, why we put the Q2? The process is not end. Even without reading an input, automatically I will move to Q2. So at that time, 3 processes will be carried. One at Q naught, the other one at Q1. The next one will be at Q2 with epsilon transition, which means no input transition. Automatically, I will take it to Q2. So here, once we read the second 0, 0, 1, 0. Okay, what else? 0, 1, 0, 1. So at Q naught, I read the 1. I'll stay at Q naught, then I'll move to Q1. And the Q1 will take me also to Q2. So we'll put here Q naught, Q1, Q2. Also, I was here in the previous one at the Q2. What if I receive a 1 while I'm in the Q2? I'll move to Q3. So Q3 will be a part of the transition with this one. Here, I have another 1. I'll stay at the Q naught. Q1 will take me to Q2. And I'll stay at the Q3, since in Q3, whatever I receive 0 or 1, I will stay in Q3. Then I read a 0. So I'll be in a Q naught. In a Q1, if I read a 0, I'll move to Q2. So Q1 is out. And also in a Q3, in a Q2, if I read a 0, I do nothing. But Q1 move me to Q2. And also in a Q3, if I read a 0, I will stay at a Q3. So at the end, I'll have 3 processes running at the same time simultaneously at Q0, Q2, and the Q3. However, do I reach to an accepted state? Do I end reading the string at accepted state? The answer is yes, because I have a Q3 where Q3 is an accepted state here. So by definition, we have an accepted state present in our example. So input is accepted. So the string W is accepted by the language L. Questions? Questions, guys? Is that clear? Answer me in chat.
Actually, I wanted to ask, I think I was a bit confused with the bottom half of the chart. After
here.
Okay, yes. So after the row that says Q0, Q2, and how that says 1, why is that the case?
Because it's the previous case, because we receive a 0 here. Here we were in Q0, Q1, and the Q2, right?
Mm-hmm.
Let's repeat it from the beginning. Okay. We have an input string 0, 1, 0, 1, 1, 0. Okay. Back to the diagram. If I receive a 0, where I will stay? Q naught. I'll not move anywhere else. So in a Q0, if I receive a 0, I'll stay in Q naught. Clear?
Yep.
Okay. Then what is the next bit? The next bit in my string is 1. And I'm at Q naught. Okay. Here at Q naught, if I receive a 1, either I'll move 2 or I'll stay in Q naught. At the same time, a new computation path will start running at the same time while I'm in Q naught, and it will take me to Q1. Clear till here?
As well as Q2 because of the epsilon transition, right?
Yes, and even with no input, with no any input, it will move me in a third path to Q2. So what are the path after reading the first one? It's Q naught, Q1, Q2. Clear?
Mm-hmm.
The next symbol is 0. Let's back. I'm in a Q naught. I read a 0, I will stay in a Q naught. We put it here. Also, I'm in a Q1 and read a 0. What I will go, where I will go? To Q2. Right? And I'm in a Q2. Is a Q2 if has the option to read a 0?
No.
No. So I will say at a Q2. I will not write Q naught, Q2, Q2. No. We put the state once. Clear?
Okay.
Okay. And now we are at Q naught and the Q2, and we read another one here. So in a Q naught, if I read a 1, I will stay in a Q naught, then I'll move to Q1 and it will take me to Q2, which means I'll put the Q naught, Q1, and the Q2. Clear till here?
Yep.
Q naught, Q1, and Q2. Okay. Also, I'm in a Q2. Before, there is a process at the Q2 running. In a Q2, if I receive a 1, where it will take me? To Q3. So we add Q3 here. Done? Then the next one, I read the other one here. So I'm in a Q naught, Q1, Q2, and the Q3. We'll see. In a Q naught, if I read the 1, it will take me to Q naught and the Q1. We put it here. And also it will take me to Q2, as we know. Okay. And in the Q2, if I read a 1, it will take me to Q3. So we put here Q3. Then at all states, we read a 0. So in a Q naught, we will stay in a Q naught. In a Q1, it will take me to Q2. So Q naught, Q2. And if I'm in a Q2 and read a 0, nothing will happen. And in a Q3, if I read a 0, I will stay at Q3. That's why Q2 opt out of the list. Sorry, Q1 opt out of the list. So Q naught, Q2, and the Q3. Is that clear? And since
Okay, so
the
because of that last
stage,
input,
if we have an accepted state, then the string is accepted.
Okay.
So this
it's because of that.
Yeah.
Sorry.
Right.
So it's because of that last 0 that we have that Q0, Q2, Q3.
Yes.
Okay.
Considering that if we apply this 0 to those states, what will happen? We'll put the new states based on this input. So this input, we have to apply it to this state and see what are the new states. Clear, guys? Everybody clear? Thank you, Daru. Any other question, guys? Don't hesitate to ask. I'll not give any more example. I don't want you to be confused. Last year, I give it in one class, and some students suffer till the mid of the course, and even in the midterm, because last year we have a midterm. So this year, I slow down, because if we build this strong foundation in the first 5 handouts, the other 7 handouts will be piece of cake for all of you. So this is the second time I'm teaching the course. That's why I'm a bit slow. I know we are delayed, but we can recover from the tutorial. But my target, I need the 151 student to understand every single concept. My job to let you understand, and you know, it's a kind of rigid course, so I'm trying to make it a bit smoother to understand. Because we talk about fundamental level of computation, you know, the level above machine language, how the basics of programming languages work, what happened actually inside when we read your program, when the compiler or interpreter read your program. So I need you to understand this concept and link it in your mind. That's why I'm giving like injections in a step-by-step manner. When Q1 goes to Q2 with epsilon, why does it result in Q1 and Q2? Yes. So Q1 goes to Q2 with epsilon. You mean when you receive a 1? Richard? Okay. When we receive a 1, we are here, Richard, at a Q note. We receive a 1. When we receive a 1, it will move me to Q2. But here I have the epsilon option. Epsilon option, that means there is no input. And we are talking about parallel processing. Processes and computation are carried out at the same time, simultaneously at the same time. We have multiple processes, or in today's term, multiple threads are running at the same time. So even if I don't receive an input, if I reach to Q1, it will take me to Q2. At the same time, there is a process stay at Q1. That's why we give Q1 and Q2. Is that clear? Good. Other question, guys, about today and yesterday classes. If we understand these concepts, we'll move on smoothly with example next class. Because the pumping lemma need us, and to prove that the language is regular or not regular, need to understand all of these concepts. Also, I will touch base with some kind of mathematical proofs, just as a reminder. Just as a reminder. Because these things, I found it was difficult to student last year. That's why this year I add these extra resources and extra explanation to make things are smoother. Don't depend on the handout only. So there is a handout, guys, which is I designed last year for students materials, which is handout 5A. I make it, yes. I will upload it maybe today. That proofs techniques, the mathematical proofs techniques. It is a simple handout. So we'll talk about, we'll touch base about mathematical induction. We'll talk about contradiction, direct proof, proof by contradiction, pigeonhole principle, pumping lemma, and non-regular languages. So these things, I will also touch base with it next class, next week, to make things are smooth. This is an extra handout I added last year, and it was very beneficial. But this will happen after we have enough example in non-deterministic finite automata, how the graphs, how the table, how the transition carried out. So I make sure before going to regular and non-regular languages and the pumping lemma, everybody at the same page. Tonight, I will upload the videos of today's class and yesterday's class. And if you have any question or ambiguous question, don't hesitate to just let me know that you will come to the office hours on Wednesdays. In the multiple thread example, when one of the threads gets to accept, does the whole input accept, or do all threads need to get the accept? No. If we arrive at any with this input, with this, this is 3. If we arrive at one of these steps, this is our final threads. Since there is a threads end at Q3, which is the accepted state, then we will accept the input. Doesn't need that all path arrive at accepted state. If there is one accepted state, then we will accept the input, Richard. Rachel. Why you sad with pigeonhole? No, I'll not make it complicated. It will be piece of cake. No worries. No worries. And normally our proofs are by contradiction, which is by assumption. But we'll take the pigeonhole concept, not the proof itself. I haven't. No worries. I'll not ask you to use the pigeonhole principle to prove something. We'll use the concept to add 1 to the assumption, to the power that we'll have. You will see. You will see. You will understand it. No worries. Okay, guys. Any other questions? For Q note, Q2. Why did it skip Q1? Where we skip Q1? You mean here? Which step? 4th line. 1, 2, 3, 4. Here. Okay. Now let's back. We are at Q naught and we receive a 0. We are at Q naught and we receive a 0. So we will stay at Q naught. Then we receive a 1 and we are at Q naught. There is only one process at that time running at Q naught. Then we receive a 1. We will stay in Q naught and we'll move to Q1. And by definition, since we have an epsilon, automatically a third one will start working at the same time in Q2. That's why we put Q0, Q1, Q2. Then we receive a 0. So if I'm in Q0 and receive a 0, I will stay here. So we move to down Q0. And I'm in Q1 and receive a 0. I'm in Q1 and receive a 0. I'll move to Q2. We put Q2. And I'm in Q2 and receive a 0, I'll do nothing. That's why the 0 input move me from Q1 to Q2. Is that clear? And I'm not anymore at Q1 at that time. Okay, good. Okay, guys, questions? So I'll make assignment 1 and assignment 2 both together as 10 questions. Each one is 5. Or the total of assignment 1 and 2 are 10 questions, maybe it's 6, 4, 7, 3, I'm not sure. Okay, I'll explain it now, line 3. And there is a submission date for assignment 1 and a submission date for assignment 2, but I will release them both together because by the end of next week, assignment 1 and 2 material are covered both due to the new way we move the classes. And quiz 1 will be carried out not next week, might be Friday the week after. This is an approximate date. I will make the announcement on Sunday for you all, or early Monday. So about assignment 1, 2, 3, and 4, quiz 1, 2, and 3, and 4. Also, before next class on Thursday, the groups will be ready and the presentation days will be also announced. And also, since I'll give approximate date for assignments, I will announce the approximate date for tutorials. I will consider the reading week, don't worry. Normally when I said next week, if it's reading week, then I mean the week after. So no worries. Or I can make, if you want, guys, assignment 1 and 2 submission after reading week. So you have enough time to do all of those. We will see. We can discuss next Thursday before the announcement of assignments. I'll take votes and we will see. Normally, I don't want to put a date that will affect the student, so you have enough time to do your tasks. However, you know, the last assignment will be first week of April. If we took more tutorial session as classes, we might finish last week of March. So you have enough time before the final exam and our course is done. We will see. I don't want to put a lot of pressure on you guys. However, taking extra classes before, that would help us by the end of the term. So if you have nothing to ask, and what is the point of having 0 and epsilon as the transition if it moves from Q1 to Q1 automatically? The point is, we are talking about non-deterministic finite automata, and there is a processes need epsilon, which is the empty string with no input. We have some processes, whatever happen, whatever the input or the next input, that I need to move to a certain state of the program. So this is an example. We can put it at between Q2 and the Q3 or at the Q node. This is an example to let you understand the concept. And the epsilon is required. You will see in many examples later on in handout 6, 7, and 8, you will see that what is the job of epsilon, why we need epsilon. Because sometimes it helps the program to move out of infinite loop or infinite operations. Is the selected path just one that reach the accepting state? Any path reached to the accepting state is an accepting path. But if at least we have one path, then we can accept the input. Okay, there is a question before I missed it. Could you explain line 3? Okay, here. We were at Q node and we receive a 1. We were at Q node here and we receive a 1. So if I receive a 1, either I will stay in a Q node and at the same time, I'll move to Q1 because I receive a 1, and we said these are parallel processes happening at the same time. And since in Q1 I have the epsilon, which means if I don't receive an input, also move to Q2, then I'll be at the Q0, Q1, and the Q2. This is the third line. And if you mean if we receive a 0, what happened in the fourth line? Okay, we are at Q, we have 3 processes running right now. Q0, Q1, and the Q2, and we receive a 0 for all processes, what will happen? In Q0, I will stay at Q0. In Q1, if I receive a 0, I have to move from Q1 to Q2. So Q1, opt out. So I'm at Q2 because Q1 receive a 0. And also, there is a third process was carried out at Q2 and receive a 0. Here, if we receive a 0, we do nothing. So we stay at Q2. That's why we cannot say Q0, Q2, Q2. We put the Q2 one time. Is that clear? Okay, good. You are welcome. Any other questions, guys? You see, some people will say, oh, only 3 pages and we have a 2 hours class. I know there is a lot of question because, and it's with one example. That's why I'll take it like step by step. Last year, I make it all at once, handout 4 with examples, but the student got confused. So when I move to handout 5 with pumping lemma, I'll find a problem. That's why I add the mathematical proof. I did a lot of example after 5. That's why this year I'll take it slowly at the beginning. Once we have a solid foundation, then we can build on. It will be very quick the later. However, I'll not move to any new concept or idea without making sure that the student understand this course or this material. Okay, if you don't have any question, we can leave. Have a nice weekend, guys, and see you next Thursday at 3:30 or 4. I might make announcement at 4. Some students send me if you can delay it for 30 minutes. So see you guys on Thursday around 3:30 or 4. We will see. I'll make an announcement and wish you a happy weekend and stay safe. Bye-bye. I'll stop recording now.